Hi learners! Welcome to Math is Fun with Sir O. Today, I will be discussing the language of sets. So we're going to learn set symbols and operations. And before we start, I'm going to read our learning outcomes. First, we're going to discuss the definition of set, subset, and proper subset. Second, determine whether a set is in raster or set builder notation. Third, illustrate subset and universal set using Venn diagram. Next is list all possible subsets of a given set. And lastly, know how to perform set operations. Would there be any question with our learning outcomes? None. Okay. Now, before we go to our discussion proper, I have here a problem. So I'm going to read first our problem. So place 8 balls in 3 baskets of different sizes so that there is an odd number of balls in each basket. Now, if you want to answer this problem, you can pause our video. Okay, so what do you think will be our answer? So again, if we are going to answer this, we're going to follow the certain condition in our problem. First, we're going to divide our 8 balls. So we have here our 8 balls into 3 baskets. Okay, so meaning that each basket should have an odd number of balls. So that would be our condition. So what do you think will be the number of balls in each of the basket? All right, so if you have no answer, definitely it is correct. All right, so for this problem, the solution set is equal to empty set or null sets, which means that we could not obtain an answer in our problem. Very good. Since we're talking about empty set, we're going now to discuss our lesson for today, which is about set. So what definitely is a set? Let's have our set vocabulary. First, number 1. Set is a collection of related and well-defined objects. So meaning if you have your collection of objects, such as you are fond of collecting your books, collecting clothes, collecting your caps, or collecting stamps, so that would be a set, because a set is a group or collection of things. George Cantor introduced the word set in 1879. So meaning he is the one who coined the word set to be called as the term for the groups of objects. Since we mentioned that a set is a collection of objects, so we will have some example. So number 1, we have a collection of numbers. So our set A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. It could be also a collection of colors. So we have there set B is equal to red, yellow, and blue. We have also another set, which is a set of numbers bounded by 2 numbers. So in our number line there, we have your 0 and 0.5, right? So as you can see that the points are not solid. So meaning the elements that would be included in our number set would be 1, 2, 3, and 4 only. 0 and 5 are not included since, all right, our points there says that it is not included. They are just the boundary, but then they are not included in our set. Okay. Number 2, element. Element is the object in the set. It is denoted by our symbol E. So the elements can be numbers, letters, or anything. So in our examples here, we have our numbers as our elements. In the second example, we have colors as our elements, and we could also use letters to be elements of our set. All right, any question? Number 3, braces. Braces are used to enclose the elements of the set. So meaning if you have your braces, so inside of your braces will be your elements. So you have to have your open and closed braces. Okay, so that would be the boundaries of your elements, right? Number 4, uppercase letters. So we have your A, B, and C. So they are used to name a set. Number 5, lowercase letter a, b, c, sometimes used as elements of the set. So you have to remember that the lowercase letters or the small letters are not used to name your set. Sometimes they are only used as elements of our set. Any question for our set vocabulary? None? Let's move on. So now, what is a subset? So we already know what a set is, and now, what is a subset? So we have here a representation. So what is the possible outcomes from rolling a die? So of course, we know that a die has 6 faces. It's possible that in one roll of a die, you will have one outcome, right? Because it will only give you one face of the die. But since we have 6 faces, of course, there will be 6 possible outcomes in rolling our die. And thus, we have to name our set as A is equal to 1, 2, 3, 4, 5, 6. All right. Now, what is a subset there? So if we're going to only to include your possible even outcomes, then that would be A sub E is equal to 2, 4, and 6. Because 2, 4, and 6 are the possible even outcomes in our universal set. Okay? The universal set is the largest possible set for a given scenario. So in our case, this is our universal set. It has 6 possible outcomes, right? A sub E is a subset of all the possible outcomes because it contains some of the elements of A. So meaning when we say subset, a subset has elements which are only part of the elements of our universal set. And subsets are denoted using this symbol. Thus, A sub E is a subset of A. All right, so any question for subset? None, okay. So now let's have a short exercise. Let M is equal to GREAT. So tell if each of the following set is a subset of the set M. So let's start with AT. Is that a subset or not? Yes, very good. Why it is a subset? Correct, because A and T are also elements of our universal set M, right? So the elements A and T can be found here in our elements of M. How about for number 2? EAT, is that a subset of set M? Yes, definitely, right? Because EAT are also elements of our set M. Now for number 3, we have your TEAM. Is that a subset of our set M? No, right? Because we have here one element which is M, but then it is not an element of our set M. Okay? How about for number 4? We have RGETA. Definitely, it is also a subset of our set M. So meaning, the set itself is also considered a subset of our set, right? So again, the set itself is also considered a subset of our set. Okay, you have to remember that. Now, how many subsets are there if the set has, let's say for example, we have one element. So who can tell me how many subsets can we be able to obtain if we have only one element? All right, there are 2 possible subsets. Okay, how about if we have 2 elements? Okay, 4 subsets. How about for 3 elements? 8 subsets. For 4 elements, 16 subsets. So if we're going to get the pattern of how we are getting the subset, we are only using this formula. So that would be 2 raised to our n. So meaning, right? So 2 there will be our constant number and it is raised into the power of n. So meaning our n there would be the number of elements of our set. Okay? So for one element, then the answer would be 2 raised to 1. So that's why we have there 2 possible subsets, because 2 raised to 1 is equal to 2. Now, what are these subsets of one element of the set? Okay, so say for example, if we have set A and we will have only one element, okay? So what do you think will be the possible subsets of our set A? So let's say our element there is just 1. What do you think will be our possible subsets? Okay, so one possible subset, as I mentioned earlier, that a set itself is also a subset of our set. Okay, and what will be the next subset? What will be our next subset? All right, and that would be our empty set. Okay, empty set. So that's why we have 2 subsets if you only have one element of the set. Any question? None. Now, what is an empty set? The empty set or null set is a special set. It contains no elements. It is usually denoted as your open and closed braces. We call it empty set, or this P sign here, which is null set, right? The empty set is always considered a subset of any set. So for all set, usually we have our empty set as one of its subsets, okay? How about if we have this set, okay? Is this set 0 empty? Yes or no? It is not empty. Why? Because it contains the element 0. So meaning 0 is still considered as element as well of a set. So do not be confused with this example. All right, any question? Okay, so let's proceed with proper subset of a set. So earlier we have discussed the subset of a set. Now we have another, which is the proper subset of a set. So A is a proper subset of B. So this is the symbol for proper subset. So A is a proper subset of B if and only if every element of A is in B, but there is at least one element of B that is not in A. All right? So let's have an example for this. So let A is equal to 1, 4, 3, and B is equal to 1, 2, 3, 4, 5. Now, is A a subset of B? Let's see. So let's verify. So A, according to our condition, if and only if every element of A is in B. Now, we have elements 1, 4, 3. Can we find these elements in our B? Yes, so we have also elements 1, 4, 3 also in B, right? And what else? There is at least one element of B that is not in A. So meaning we have elements of B that are not in A, and they are 2 and 5. So they are not in A. So meaning if that satisfies our condition, then we can say that A is a proper subset of our B. Okay? Now, what if we're going to interchange? Is B a proper subset of A? Okay, so let's check. So now let's consider our set B. So first, if and only if every element of B is in A. So are all elements of B are in A? Definitely not, right? Because there are 2 and 5 that are not elements of A. So with that, it shows that B is a proper subset of A is false. All right, any question? Okay, let's proceed. Now let's proceed to mutually exclusive sets. We say two sets A and B are mutually exclusive if the intersection of A and B is a null set. So you think of this as two events that cannot happen at the same time. For example, is it possible for you to attend our class in GE Math 1 at the same time you're attending your class in another subject? Of course not. And that is an example of mutually exclusive set. So meaning there will be two events that cannot happen at the same time. Cardinal number of a set. The cardinal number of a set is the number of elements in the set and is denoted by n of a. So you're going to read this as n of a, right? For example, let A is equal to 2, 4, 6, 8, 10. Then our n of A, or our cardinal number of set A, is equal to 5. So how are we going to do that? So of course, just count the number of elements of your set and that's it, the cardinal number of our set. So if you want to know the cardinal number for the union of two sets, so we can use this formula, okay? So n of A union B is equal to n of A plus n of B minus n of A intersection B, okay? How about if we're going to get the cardinal number of the complement of a set? So we can use also this formula. So that would be n of A plus n of A prime is equal to n of U. Okay, U there will be the union, right? So any question for cardinal number of a set? None. Okay. Now, let's go to how the sets are being written. So let's start with our roster notation. So roster notation is the method of describing a set by listing each element of the set. Example, let set A equal to the set of odd numbers greater than 0 and less than 10. So meaning if you're using roster notation, you are writing down all the possible elements of the given set. Now, in our example, look at this. We have to consider the odd numbers between 0 and 10. And what are those numbers? So our answer would be A is equal to 1, 3, 5, 7, 9, right? And this way of writing your set is what you call your roster notation. All right, any question? None. Okay, so now let's go to the set builder notation. So this time, set builder notation is used when it is not convenient to list all the elements of a set. So we use a notation that employs the rules in which an element is a member of the set. So meaning if it's very difficult for us to write down all the elements of your set because they are many, then we're going to use the set builder notation. Example, all right, so we have there set V is equal to people such that citizens registered to vote in Maricopa County. So according to our definition, we are going to use annotation that employs the rule, okay? So of course, first we're going to have an element as a member of the set. And the element that we are using here as a member of our set is people, okay? And followed by the rule that it employs. And what is the rule? Citizens registered to vote in Maricopa County. Meaning, the set that we are talking about here will be the people that are only citizens registered to vote in Maricopa County. It is not about people who are not able to register, but only those citizens that were able to register to vote in Maricopa County. And by the way, this symbol here is read as such that. All right? Okay. So another example. A is equal to X such that X is greater than 5. Of course, when you say a number greater than 5, so it would be 6, 7, 8, 9, and so on, right? So all of those are numbers greater than 5. And what would be your element number there? So it would be represented by X, okay? because it could be any number. It could be 6, it could be 7, or so on, right? But then we are going to emphasize that this number here should be an element of a number which is greater than 5. Okay, so in other terms, that would be the set A that has all real numbers greater than 5. Okay, so again, the symbol, this one is read as such that. Okay, so that's how you're going to make set builder notation. Okay, now how about if we have to write sets of natural numbers? So that would be capital letter N, and set of whole numbers, capital letter W, in roster form. How are we going to do that? I mentioned last time that if it is inconvenient for us to write the set because it has infinitely number of elements, then we're going to use your set builder notation, right? But then we can still write this down using our roster notation. And how is that? Okay, so for our solution, so we have your n as our set of natural numbers. That would be equal to 1, 2, 3. Then we have to introduce our ellipsis. So these 3 dots here is our ellipsis, meaning the numbers are still continuous, right? It does not end, or it is infinite. So you can put there our symbol for infinity. Okay, so that's how you're going to do using the roster form notation. Okay, how about for the whole numbers? Of course, when it is a whole number, we start counting from 0, 1, 2, 3, followed by the ellipsis. Okay, and then our infinity. Okay, so I am introducing this because in some higher mathematical books, you can see these notations, right? For you not to be confused that our set of numbers can be also written using your roster notation. Any question? None. All right. Okay, so this time we're going to write the set of rational number R in set builder notation. So for our solution, okay, that would be R. Okay, capital letter R is equal to X, right? So our X there is an element of our rational number, right? And there will be a condition such that X is equal to P and Q. Why is it that we are equating X as equal to P and Q? What do you think? All right, because when you say real number, it is written as a fraction. So P over Q is the symbol for our fraction. So where P and Q are elements of C. So meaning it could be a number from your set of integers. It could be a negative number. It could be positive number, including your 0. But then we have to specify that Q should not be equal to 0. Right? What do you think? Why do you think that it is not possible for us to have a denominator equal to 0? Okay. Say, for example, we have 3 over 0 or 3 divided by 0. Is it possible? Not, because our answer here would be undefined, or it will become infinity, right? So it is not correct that if we're going to have our fraction, we have to put 0 as its denominator. So if you're going to input that using your calculator, so the calculator will say syntax error, so meaning undefined. So you will not have any answer for your fraction whenever you have 0 as your denominator. Any question? None. Okay. All right. So we're done now with our set builder notation. Now let's go to complement of a set. The complement of a set is all of the elements in the universal set, but not in the set of interest. All right. So complements of sets are denoted using a prime symbol. So meaning if you have your apostrophe, right? So meaning that would be complement of a set. Say, for example, your set is A, right? And if you're going to put there your prime symbol, that would be read as A prime. Okay, meaning you are talking about the complement of set A, right? And how are we going to do that? Okay, and how is set of complement being done. So let's go back to our example earlier. So we have there our universal set, which is set A is equal to 1, 2, 3, 4, 5, 6. And these are the set of possible outcomes when rolling a die. And so we have also set of even outcomes. And we have there A sub E is equal to 2, 4, 6. Now, what is the complement of the set of even outcomes when rolling a die? If that is the question, then our set of interest are these elements of our possible even outcomes. Okay, so meaning this is the set of interest that we are talking about. And according to our definition, right, the elements that we're going to include in our complement of a set are those elements that are not included in the set of interest. And if we have 2, 4, 6 as our set of interest, then we have 1, 3, and 5 as the numbers or as the elements that are not included in the set of interest. And so, all right, so our A sub E prime or complement of our set A sub E is equal to 1, 3, 5. So, in other words, so when we say complement of a set, we are actually talking about the opposite of what is included in the set of interest. So if, right, if we are getting the complement of even outcomes, of course, what are the opposite of even outcomes? Right, you have the set of possible odd outcomes, right? Any question for the complement of a set? None. Okay. Now let's go to union of a set. The union of two or more sets contains all the elements in all the sets. All right. The union of sets A and B is the elements in either set A or B or both. So unions of sets are denoted by the symbol U. Example, what is the union of set A, the outcomes of rolling a die, and set B, all possible integers from 7 to 11. All right. So we have our set A. So these are the possible outcomes of rolling a die. So we have 1, 2, 3, 4, 5, 6. And for our set B, 7, 8, 9, 10, 11. These are our numbers or elements of our set B. Now, if we're talking about union of set A and set B, we're going to collect or incorporate all the elements of the two sets in one single set. And that would be A union B. So this will be the symbol for A union B. And as you can see that we have there the elements 1, 2, 3, 4, 5, 6 as the elements of set A, and followed by 7, 8, 9, 10, 11 as elements of our set B. So meaning you combine all the elements of the two sets. So that is how you get your union of the two sets. Okay. Any question for union? None. Now let's go to another one, intersection of a set. So the intersection of two or more sets contains all the common elements that are in all sets. So meaning what will be the common elements that can be found in your set A or set B. Okay. All right. And the intersections of sets are denoted by the symbol, this symbol. This is like an inverted union symbol. Okay. So what is the intersection of set A, the outcomes of rolling a die, and set B, all positive integers between and inclusive of 4 and 9. So let's write our set A. So 1, 2, 3, 4, 5, 6, and set B 4, 5, 6, 7, 8, 9. Okay, so we mentioned there that we are going to get the common elements, and we have these 4, 5, and 6 that were the common elements of both set A and set B. Thus, our intersection of set A and set B is equal to 4, 5, and 6. So if you're going to construct your Venn diagram, your two sets there, the two circles are overlapping. Okay, so this set A that we have here, we have 1, 2, 3, 4, 5, 6. For set B, we have 4, 5, 6, 7, 8, 9. And in the middle, the overlapping portion of the two sets will be our intersection of a set. So any question for intersection of our two or more sets? None. Okay. So let's continue. Now let's go to disjoint sets. Disjoint sets are two or more sets that have no elements in common. So therefore, the intersection is an empty set. Okay? An empty set. All right. So say, for example, a set of all 3D shapes with a curved surfaces. So we have there your sphere, this one is your cone and your cylinder, right? So these are our 3D shapes. And our set B are all polyhedrons. Okay, look at this. So we have your prism, a triangular prism, you have your tetrahedron, right? So as you can see that you cannot have any common elements between the two sets, right? And that's why they are called disjoint set. And if we're going to write the symbol, that would be A intersection B would be equal to null set, right? Null set simply because you cannot see any common elements between our two sets. Any question? None, right? Now let's go to the set operations. So we're going to add and subtract our two sets. Okay, so we have here set A is equal to 1 to 3 and set B is equal to 1 and 3. So we're going to find letter A, the sum of A and B. For letter B, the difference of A and B. And for letter C, the difference of B and A. Now let's start with our letter A. A plus B. Okay. All right. So in our A, we have 1, 2, 3. We're going to add our B. So as you can see that 1 and 3 can also be found here in our B. So 1 and 3, right? So for our solution, A plus B is equal to 1, 2, 3 still, right? So meaning we don't write the same elements twice in our solution. So if you have 1 and 3 that can be found in both of our sets A and B, then do not write that twice. That's why our answer will be 1, 2, and 3 only. Thus, if we're going to break down your solution, that would be equal to A because our elements 1 to 3 are exactly the elements of our set A. All right? Do you follow? Okay, so now let's go to subtraction. So what is A minus B? Look at your set A. So we have 1, 2, 3, and we're going to subtract the elements of B, which are 1 and 3. So meaning we cross out 1 and we cross out your 3, right? So the elements of A minus all the elements of B. Okay, so what will be the element that will be left in our set A? What will be the element? All right, so we have an element 2. So the answer would be A minus B is equal to 2. So now we're going to interchange our position of A and B. So this time it will become B minus A. Okay, so now let's go back to our B. So our elements of B are 1 and 3, right? So we're going to subtract elements of A. So of course, since A has 1, then our 1 here will be canceled out. And we have also 3 here. And our elements here will be canceled out. So what do you think will be left there in our set B? All right, you're correct. So there's none, right? So meaning B minus A is equal to empty set or null set. Okay, so bottom line, your A minus B, right, is different from B minus A. So you have to be careful of your set operations. So any question for addition and subtraction of two sets? Any question? None. So now let's proceed with our Cartesian product. So given sets A and B, the Cartesian product of A and B is denoted A cross B, right? So that is read as A cross B is the set of all ordered pairs AB. So meaning we will have an ordered pair, which will be the element of our Cartesian product. So where A is in A and B is in E. So symbolically, we have this. A cross B is equal to AB. So this will be our unit. So we will have an answer which has an element, which is your ordered pair. Okay, such that your A is element of A and B is also an element of B. Now, for you to have a clear picture of this, we will have an example. Example, let A is equal to 1, 3, negative 4, and B is equal to 0, 3. Now, we find A cross B, and B cross A. Start with your A cross B. Oh, look at this one. So first, we're going to pair out our elements of A to our elements of B. So let's start with 1. So 1 is paired out to 0, and 1 is paired out to 3. Right? So that will be the first step. Okay, then after we're done, now let's go to our 3. So this time, we're going to pair out our element 3 to the elements of our B. So 3 is paired out to 0, and 3 is paired out to 3. So that would be the second step. And lastly, since we have our last element there is negative 4, we're going to pair this out with the elements of our B. So negative 4 is paired out to 0, and negative 4 is paired out to 3. And that would be the last step of our Cartesian product. So these are the elements of our A cross B. So we have here your ordered pair. So meaning, as you can see here, that our A, right? Our A supplies all the elements of our X's, right? And our B supplies all the elements of our Y's, 0 and 3. All right, any question? How about if we're going to interchange? This time, we're going to have B cross A. All right, B cross A. So we have to start with 0. 0 is paired out to 1. 0 is paired out to 3. And 0 is paired out to negative 4. So that will be the first step. Then we have your next element there, which is 3. 3 is paired out to 1. Then it is paired out to 3. And then it is paired out to negative 4. And that would be the last step of your Cartesian product. Any question? Very easy, right? Okay. So now let's go to Venn diagram. What is a Venn diagram? So a Venn diagram is an illustration that uses circles to show the relationships among things or finite group of things. So by means of Venn diagram, we can now have a clear representation of how our sets are being related. Okay, say for example, if you have union of sets, if you have your intersection of sets, you could be able to do that by means of Venn diagram. You will have a very clear picture of what the set look like, right? So just like in our example here, if we have our set A and set B, then in the middle, since we have common elements between the two sets, then we have there your A intersection B. So this portion here will be the common elements that will be placed in our Venn diagram. So we have also a lot of ways in showing our sets using the Venn diagram. So if we're talking about union of the two sets, okay, so all of the colored portion here will be our union, okay? For our intersection, so only the overlapping portion will be colored, okay? And if we're talking about the complement of the intersection of A and B, to consider the set which is not included in the set of interest of our A intersection B, okay? So now I will be giving you the time to study these examples of Venn diagram in our picture. Okay. All right. So I think that would be all. So I will be giving you your assignment. So your check your progress will be serving as our assignment for this lesson. So for number 1, you're going to list all the subsets of our A. Okay. So we have 3 elements, right? And if you have 3 elements, we have 8 possible subsets. So meaning you're going to list down all the possible subsets that would be created by our set A, which has 3 elements. Then for number 2, using the figure below, you find the elements found in the indicated sets. Meaning you're going to perform the union, the intersection, the complement, the subtraction, all right, of our given sets. Okay. So another one. All right. So this time you will have different answers for this problem. So meaning you're going to use your first name only. So you have to have your personal name. So say, for example, in our set A, so that would be set of all the letters in the alphabet from A to Z, okay? For our set B, these are the set of all the vowels that we have. So from A, E, I, O, U. And for your set C, that will be all the letters of your first name. Now, what are you going to do here? You're going to draw a Venn diagram to represent these sets. And then you're going to tell me what will be the universal set and which are the subsets of our set. Okay, so this will be the Venn diagram that you're going to do. Okay, so for A, you list down there all the letters of the alphabet. For B, you list down there all the letters of the vowels or the vowels of the alphabet. And for C, you list down there all the letters of your name. Now, for the vowel and your name, you will have your common elements, right? So you have to write it here, all the common elements or letters of the vowels and your first name. Okay? And the letters that will not be included in your vowels and your first name will be placed here. All right? Any question for our lesson today? None? All right. So thank you so much for listening and for watching this video. I would like to encourage everybody to please like, share, and subscribe my YouTube channel. I will be excited to make more videos for you to learn. All right. So thank you so much. This is your Sir O. I will be seeing you back next time. Goodbye and God bless everyone.